This video is going to show you how to solve various types of equations that you might find in your algebra class, including one-step, two-step, square roots, quadratics, square, absolute value, and some other ones as well. This first one is a simple one-step equation using with addition. Something x plus 3 equals 7. Something plus 3 equals 7. Here you can just guess the answer, right? It's going to be 4. 4 plus 3 equals 7. So that's easy to solve, but if you want to do it algebraically, let me show you that. So your goal in solving an equation is to get the x variable by itself. So if I have x plus 3, in order to get rid of the plus 3, I do the opposite. I have to subtract 3. So if I subtract 3, that's going to add up to 0, and just leaving you with just the x. Now what I do to one side of the equation, I got to do to the other side of the equation. And the equal sign is what splits the equation in two halves, the left side and the right side. So from this side, I got also subtract 3. Okay, so 7 minus 3 is 4. So x equals 4. Now in this problem, almost the same. So here we got x minus 5. So again, we need to do the opposite. We need to add 5 to both sides. Okay, so remember that adds up to 0, just leaving you with just the x. And 9 plus 5 is 14. All right, so this is another one-step equation, but now involving multiplication. We have 3x equals 12, so 3 times something equals 12, and you can kind of tell that's going to be 4. 3 times 4 is equal to 12. But let me show you how to do it algebraically. So doing this algebraically, like any of these equations, we need to get the isolate the x, get the x by itself. So if I got 3 times x, I need to do the opposite. So opposite of multiplication is division. So I'm going to divide by 3 on both sides. Okay, so that causes this to be 1 or 1x or just x. And then 12 divided by 3 gives you 4. So x equals 4. 3 times 4 equals 12. And like I said, our goal is to get the x by itself. So since there's multiplication here, I got to do the opposite. I got to divide by 3 on both sides. So another equation, still doing one step, but now it's involving division. X divided by 5 equals 3. Okay, so again, we want to do the opposite. We got division. The opposite is multiplication. So I'm going to multiply both sides by 5. That ends up being 5 divided by 5, reduces down to 1. 1x or just x. And 3 times 5 is 15. So x equals 15. 15 divided by 5 equals 3. All right, so this is still a one step, but now we got a fraction 2/3 x equals 12. Now in the other equations we said we got to do the opposite. Now when dealing with a fraction, you kind of still do the opposite, but what we're going to do is multiply by the reciprocal of the fraction. So the reciprocal means to flip it over. So 2/3, the reciprocal of 2/3 is going to be 3/2. So I multiply by 3/2, 3 over 2. Okay. I'm going to multiply the other side by 3/2. That ends up, the 3's end up canceling into 1, the 2's end up canceling to 1. So you get 1x or just x. Now we take 12 times 3/2. What we can do is kind of reduce this. 12 divided by 2 is 6. 6 times 3 is 18. So 2/3 times 18 equals 12. So we had a fraction. We had to multiply by the reciprocal of that fraction on both sides in order to reduce this number down to 1x. And then you gotta multiply the other side by that same reciprocal. Okay, so now we're getting into two-step problems. So before we had to either just add one thing and we're done, or subtract one thing, we were done, multiply by something, or divide by something, or multiply by the reciprocal. So two-step problems involves doing two of those. Either you're going to do addition or subtraction, and a multiplication or division. So those two. You wouldn't really have two subtractions or two additions. You have one either adding or subtracting, and another step where you would multiply or divide, or even multiply by the reciprocal. So here, typically you want to start out with the adding or subtracting. Okay, so I want to leave. Remember, our goal is to get the x by itself. Okay, so you usually deal with that term last. Okay, so I'm going to deal with the x minus 2. I'm going to get rid of all the numbers on this side. I'm going to get rid of the 2 by doing the opposite. So if it's subtract 2, I'm going to add 2. You got to do the same thing to the other side. Okay, that adds up to 0. Negative 2 plus 2 is 0. So that goes away, leaving me with just the 3x. 10 plus 2 is 12. Okay, that was our first step. Our second step, see we got a 3x, 3 times x equals 12. Opposite of multiplication is division, so I divide both sides by 3. Okay, leaves me with just a 1x, and 12 divided by 3 is 4. Okay, so we did two steps. We added 2 to both sides and divided both sides by 3. Now, for any of these equations, you can check your answer by putting the x value back into the equation and make sure that comes out to be true. So we're saying 3 times 4 minus 2 equals 10. So 3 times 4 is 12, minus 2 equals 10. 12 minus 2 is 10. So 10 equals 10. So that's true. So if both sides equal the same number, your answer is correct. All right, so this one involves two steps again. I got a fraction multiplied by the variable, and I'm adding 3. So again, I start with whatever's being added or subtracted, do the opposite. So I subtract 3, so that adds up to 0. Subtract 3 here. Leaves me with the 2/5 x. 7 minus 3 is 4. Now when I have a fraction, I want to multiply by the reciprocal. So 5/2. Multiply that on both sides. Okay, that reduces down to 1x, or just x. Here I can take the 4, divide by 2 gives you 2, and 2 times 5 gives you 10. So x equals 10. I can check by putting that value back in. 2/5 times 10 plus 3 equals 7. Here I can take the 10 divided by 5 is 2. 2 times 2 is 4. 4 plus 3 is 7. So 7 equals 7. So that works out. So this one looks like a two-step problem, but I have two x terms in the equation. So when you see that, you want to get it to have one x term. So I need to combine the x terms together. So what I'm going to do, I'm going to take the smaller of the two. 3x is smaller than 5x. I'm going to get rid of that from that side. So this is a positive 3x. So I gotta do the opposite. I need to subtract 3x. And on this side, I need to do the same thing, subtract 3x. Okay, over here, that adds up to 0. Over here, 5 minus 3 is 2. So 2x, I'm going to bring down the rest of the problem. So minus 2 equals 10. So 2x minus 2 equals 10. Now this looks like the problem that we've done before. You're going to involve 2 steps, getting rid of this minus 2, and then dividing by the 2 to get the x by itself. So do the opposite, add 2. Okay, so that leaves me with 2x equals 12. And the opposite of 2 times x, you divide by 2. So x equals 6. Again, I can double check. 5 times 6 is 30. And minus 2 is 28. 3 times 6 is 18. Plus 10 comes out to 28. So both sides equal 28. So I know my answer of x equals 6 is correct. So this problem looks a little different than what the other ones that we've done. It's saying x squared equals 25. So if you're unfamiliar with square roots, definition of x squared, square root of x squared equals x. If something is squared, x squared, that means x times x. So that 2 was in the exponent. If I have 3 in the exponent position, that means I have 3 x's that are multiplied together. Okay, so when we have something that's squared, remember for all these equations, we need to get the x by itself, just x equals something. So basically, we're doing the opposite operations. So the opposite of something to the second power or squared is taking the square root. The square root of x squared equals x. So that gets the x by itself. And remember, when you do the one side of the equation, you got to do to the other. So I'm going to take the square root of the left side and square root of the right side. So we said square root of x squared just leaves you with x. And the square root of 25. Now, we know it's 5, right? 5 times 5 equals 25. But also, negative 5 times negative 5 equals 25. So it could be positive 5 or negative 5. So we kind of write it as this, plus or minus 5. Okay, so we got two answers, 5 and negative 5. Okay, so that's how you solve a problem that has a square in it. You want to take the square root of it in order to get the x by itself. And if you're taking the square root of a number, it could be the positive of it or even the negative of it. So we get two answers, positive 5 and negative 5. This one also involves a square in it. X squared minus 5 equals 31. Now again, we want to isolate the x term, so this is actually going to be a two-step problem. I'm going to get rid of that 5 by adding 5 to both sides. Okay, so that adds up to 0, leaving me with just the x squared. And then 31 plus 5 is 36. And to get the x squared just to become x, I got to take the square root of both sides. And remember, if you take the square root of a number, it could be the positive or negative of that number. So plus or minus 6. 6 times 6 is 36. So like I said, we have two answers, 6 and negative 6. Again, you can plug these in to solve and verify your answer. 6 squared is 36. minus 5 gives you 31. And also negative 6 squared, negative 6 times negative 6 equals 36, positive 36. And you subtract 5, 36 minus 5 equals 31. So both sides come out to the same answer, and 6 and negative 6 both work in that equation. So in this problem, we have a square root in the equation and not a square. All right, so again, in these equations, we need to do the opposite. So the opposite of a square root is going to be a square. So I need to square both sides. And if I do square root of x times the square root of x, if you remember your radicals, you end up having the square root of x squared, because you multiply what's underneath the radicals together, and the square root of x squared was just x. And when you squared the 7 times 7 equals 49. So now we have x equals 49. Now, before we said, with the square you had two answers, but here you only have one. We can take the square root of 49, that gives you 7, but we can't take the square root of negative 49, okay, because we said 7 times 7 equals 49, but negative 7 times negative 7 doesn't give you negative 49, it gives you positive 49. So in this case, if you deal with imaginary numbers, you end up getting 7i, but that's not the same as 7. So in this one, you only have one answer, x equals 49. If you take the square root of 49, that gives you 7. So again, we have a square root in here, but we need to get the square root term by itself, the square root by itself. And now we have 5 times the square root of x equals 20. So that's multiplication, so I gotta do the opposite, I gotta divide both sides by 5. Okay, that reduces down to 1. 1 square root of x, or just square root of x. 20 divided by 5 is 4. Okay. And again, when we have a square root, we need to do the opposite, so we're going to square both sides. When you have the square root of x squared, that's just going to be x. And 4 squared, 4 times 4 is 16. So here we have x equals 16. So if I have 5 as the square root of 16, square root of 16 becomes 4, and you get 5 times 4, and that gives you 20. Okay, so both sides will equal 20. All right, so this is a different type of problem that we've seen previously. This has an x squared term, but also an x term and a constant number. We have this is called a quadratic. Okay, if you were to graph it, it would give you a parabola, something like that, or that, a parabola. In order to solve this, you need to factor these, and then set each factor equal to 0 and solve. Okay, so if I look at my coefficients, I have 1x squared, plus 5x minus 36. Okay, so quadratic is in this form: a x squared plus bx plus c. Okay, so where our a in this case is 1, b is 5, and c is negative 36. Now in order to factor this, I'm going to come up with 2 sets of parentheses. Okay. Now, in order to get the x squared term, I have to have x times x. So I'm going to put an x in this first one and x here, because those two are going to multiply together. Now this last term, negative 36, is going to be equal to the number I put here times the number I put here. And the 5 is going to be equal to those two numbers I put here added together. Okay, so I need two numbers that multiply. They give you negative 36. And if I were to add those two numbers, they'll add up to 5. Okay, so first I'm going to break down 36 to see which numbers those could be. And you could have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and what, 5 goes in there? No, 6 times 6. Okay, so it has to equal negative 36, so one of these from the group have to be negative. So will any of these add up to 5 if one of them were negative? If I see 4 and 9, those are 5 apart, so I think those would work out. If I had positive 9 and negative 4, 9 minus 4 give me 5. So that seems like those would work out. Positive 9 and negative 4. Okay. Now I can just double check these if I were to multiply these out using the method called FOIL. X plus 9 times x minus 4. So FOIL says multiply these two together first. X squared, x times x equals x squared. Then take the x times negative 4. That's negative 4x. Then 9 times x is 9x. And then 9 times negative 4 is negative 36. So that gives me x squared. Negative 4x plus 9x gives me 5x, positive 5x, minus 36. Okay, so I got back my original, so that works out. Okay, so now I take each of these factors, x plus 9, and set them equal to 0. X minus 4 equals 0. So these are, our one-step problems that we've done before. Let's subtract 9 from both sides. So x equals negative 9. Here I need to add 4 to both sides. And x equals 4 there. So here we have two equations, or two answers, negative 9 and positive 4. Now what we're actually solving here is equal to 0. We're solving for the intercepts of the parabola hitting the x-axis. So sometimes you'll have two answers because it goes through the x-axis twice. Sometimes you get the vertex exactly on the x-axis, so you only have one intersection point, so you have only one answer. And then if it's above that line, you wouldn't have any answers. So when you have a quadratic equal to 0 and you're solving for the answers, you're solving for the intercepts of the parabola through the x-axis. All right, so in this problem, it's almost just like a quadratic. You have the x squared term, you're missing the x term, but then you have a constant there, negative 64. Now, this is a special one for factoring. When you see something like that, something squared minus something else squared, that's called a difference of two squares. You got two squares, and you get a difference, subtraction, between the two. Now, if you have that, a squared minus b squared, when you factor that, that becomes a plus b times a minus b. Now, if I were to FOIL this, a times a is a squared, a times negative b is negative ab, b times a is plus ab, and then b times negative b is negative b squared. Now I have like terms here. Negative 1ab plus 1ab is 0. So you're left with just a squared minus b squared. So we can apply that to this equation. Here I got x squared. 64 is really 8 squared. 8 times 8 is 64. So I do have a difference of 2 squares, where my a is x and my b is equal to 8. So I can write it as x plus 8 and x minus 8. And just like the previous problem, we take each factor and set it equal to 0. Now we set them equal to 0 because this is saying this times this equals 0. So we know anything times 0 equals 0. So that means that either one or both of these terms equal 0. So we're going to find out when this term equals 0, and we want to know when this term equals 0. So that's all that we're doing here. Okay, so x plus 8 equals 0. I want to subtract 8 from both sides. So x equals negative 8. Here I want to add 8 to both sides. So x equals 8. So I'll get 8 and negative 8. Now this one looks different than the other ones we've done before. These vertical lines mean absolute value. So absolute value is how many units are you away from 0. So if I were to look at the number line, I have 0 in the middle, 1, 2, 3. On the left side you would have negative 1, negative 2, negative 3. If I want to know the absolute value of 2, how many units am I away from 0? If I look here, 1, 2, so I'm 2 units away. If I look at absolute value of negative 2, I'm also 1, 2 away from 0. So what ends up happening is you basically end up just making whatever is inside positive. So absolute value of 2 is 2, and absolute value of negative 2 is also 2. So here, I want to know the absolute value of x equals 10. What values of x, when you take the absolute value of it, give you 10? So we know absolute value of 10 gives you 10, and the absolute value of negative 10 also gives you 10. So our two answers are 10, x equals 10, and x equals negative 10. Okay, so that's how you solve an equation using absolute value. So let's take it a little bit farther. All right, so this one's saying negative 3 times the absolute value of x equals 15. So like in the other problems, we want to isolate the x value. So here we want to isolate the absolute value of x. So that's negative 3 times the absolute value of x. So I'm going to divide by negative 3. So it leaves the absolute value of x equals negative 5. Remember what we said, we basically take the positive of this, what's inside the absolute value, as the answer. So is there a way where I can take the absolute value of x and give you -5? No. So this is basically no solution because there's no value of x where that absolute value of it will give you -5. Now if the problem was this, I had -15 here. If I divide that by -3, that give me absolute value of x equals 5. And then we could say that x equals 5 and x equals -5. So two answers, 5 and -5. All right, so one step farther than that, we have more than one term inside the absolute value. We have absolute value of x plus 3 equals 7. So if we know the rules from before, what's inside the absolute value could equal 7 or -7. Now, both those would work out. So if I did that, x plus 3 equals 7, and x plus 3 equal -7, those are two scenarios those would both work out inside here. If this equals +7 or if this equaled -7, it would work out. So if I subtract 3 here from both sides, that give me x equals 4. If I were to subtract 3 from both sides here, x would equal -10. All right, so let's try both of those out. That's the value of 4 plus 3 equals 7. Okay, absolute value of 4 plus 3 is 7. And absolute value of 7 is 7. So that works out. Give that a little check mark there. Here, if I insert -10 plus 3, absolute value of -10 plus 3 equals 7. -10 plus 3 is -7. And then the absolute value of -7 is 7. So that works out. So in this case, when we have absolute value, we have two answers, almost kind of like the square, the problems with the quadratic or even square. So these have two answers. So this problem looks kind of familiar. We've got an x squared term, an x term, and a constant. I guess it's a quadratic. We know we're going to have two sets of parentheses in order to solve this. So our first method, we're going to be just trying to guess what numbers need to work inside here. So I know I need an x and an x. Okay. And then I know that to get the -2 here, I have to multiply two numbers together. That has to be 1 and 2. And one of them has to be negative. So let's just assume that this one's negative. And then in order to get the 6, I need a number here times a number here. So let's just say if this is 3 and this is 2, my other choices would be a 1 and 6. And this would have to be positive. Give me the 1 times -2, give me -2. Okay, so here I just guessed, so did it work out? If I multiply this out, it gives me 6x squared. 3x times -2 is -6x. 1 times 2x is +2x. And 1 times -2 is -2. Okay, so here I have, or reduce it, combine like terms, -6 plus 2x is negative 4x minus 2. So that's different than our original. So that's not the correct one. So if I try again, so again, I need 1 and 2. Let me just put the 2 here and the 1 here. And again, I need 6 with the first two terms here. So let me try 3 here and 2 here. And let's try a negative here and a plus here. So if I were to FOIL that, you get 3x times 2x, 6x squared. 3x times negative 1 is negative 3x. And 2 times 2x is 4x. And 2 times negative 1 is negative 2. Okay, so that gives me 6x squared. Negative 3 plus 4 is positive 1, so positive x. 1x minus 2 equals 0. Okay, so that is the same as our original. So these are the factored terms, those work out. So if I take each of those, 3x plus 2 equals 0, and 2x minus 1 equals 0. Okay, so our equation equals 0, so I set each factored term equal to 0. I subtract 2 from both sides. Gives me 3x equals negative 2. And then I need to divide both sides by 3. So x equals negative 2/3. And then here I need to add 1 to both sides. Leaves me with 2x equals 1. And then divide both sides by 2. So x equals 1/2. So our two answers are x equals negative 2/3 and x equals 1/2. So here I just did guessing. I know that I need two numbers in the front here to give me 6, multiply to give me 6. And I know the last two numbers need to multiply to give me negative 2. So you try different combinations there, and you can find the right factored terms, and then you can set them equal to 0 and solve for x. Now another way to solve these, instead of just guessing, you can do this systematically. Remember the quadratic is really ax squared plus bx plus c equals 0. That's the generic form. Now when you have a above 1, in this case a is 6, b is 1, c is negative 2, what we're going to do, we're going to take a times c. It's going to be 6 times negative 2. It's going to give me negative 12. And our b is 1. So I want to find two numbers that multiply to give me negative 12 and add up to 1. So I'm going to find all the combinations that multiply to give me 12. Be 1 times 12, 2 times 6, and 3 times 4. Now, this needs to multiply to give me negative 12, so one of these from each group is going to be negative. And when I add them together, they need to add up to 1. So I can kind of tell that's going to be the 3 and 4 because they're 1 apart. Okay, in order to be a positive 1, add up to be a positive 1, the bigger number needs to be positive. So 4 needs to be positive, and the 3 will be negative. Negative 3 times 4 gives you negative 12, and negative 3 plus 4 gives you positive 1. Okay, so once we know those two numbers, we're going to rewrite our equation. Okay, you're going to keep the 6x squared, but you're going to change the x term to be negative 3x plus 4x. Those are the two numbers that we just found, negative 3 and positive 4. So we really didn't change the problem too much because this is still in the middle, still adds up to positive 1x. Okay, so the way we're solving this is called solving it by grouping. Okay, so we're going to do, after we found those two numbers, we're going to group the first two together and group the second two together. After we do the grouping, we want to factor out the greatest common factor between this first group. Okay, so 3 can divide into both of these. 3 can divide into 6. 3 can divide into 3. You get an x squared term and an x. So the common there is just an x. So I can factor out 3x. Okay, if I factor out 3x, I basically divide this by 3x. 6 divided by 3 is 2. X squared divided by x is x. So if I were to multiply those two together, 3 times 3 is 6. X times x is x squared. Okay. Now if I factor out 3x here, I'm going to divide this by 3x. 3x divided by 3x is just 1. Okay. So if I were to multiply this back out, I will get my original, which it works out. Okay. The next grouping here, 4x minus 2. What's the greatest common factor there? 2 can go into 4, 2 can go into 2. So I can factor out the 2. Only one has an x term, so I can't factor out an x at all. Okay, if I divide it by 2, leaves me with 2x here. If I divide by 2 here, leaves me with negative 1. If you notice, you got 2x minus 1 here and 2x minus 1 here. When you're factoring by grouping, both of these need to come out to be the same for other work. If they don't come out the same, that means you did something wrong. All right, so from there, I'm going to factor again. Each of these terms have a common factor of 2x minus 1. So I can take out the 2x minus 1. This one was times 3x, so it's going to be 3x here. This was times 2, so it's going to be plus 2 here. And I just carried that sign down the match. So after I factor this is 2x minus 1 and 3x plus 2, that equals 0. So again, I'm going to take each of these factors, set them equal to 0, and solve. So if I take 2x minus 1 equals 0, and 3x plus 2 equals 0, I'm going to add 1 here to both sides. Using with 2x equals 1, divide both sides by 2, so x equals 1/2. And the second one, I subtract 2 from both sides. Using with 3x equals negative 2, divide both sides by 3. That gives me x equals negative 2/3. Okay, so just like we did the last one by guessing, we still ended up with the same answers. X equals 1/2 and x equals negative 2/3. Now there's a third way to solve this by using the quadratic formula. So the quadratic formula, now, so remember our generic quadratic form was ax squared plus bx plus c. Now the quadratic formula says negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2a. This is what x is going to equal. X equals that. So if you plug in your numbers for a, b, and c, you can solve. So remember, our a is 6, b is 1, our c is -2. All right, so if we use our quadratic formula, negative b, or -1, plus or minus square root of b squared, so 1 squared minus 4 times 6, the a term, times the c term, -2, all divided by 2 times a, 2 times 6. Now if I look inside the radical here, I got 1 squared minus 4 times 6 times -2. So -1 plus or minus, so it's going to be 1, and -4 times 6 times -2. Okay, so I got 6 times 2 is 12. 12 times 4 is 48. I got 2 negatives. 4 is negative, 2 is negative, so it's going to be 1 plus 48. And on the bottom, 2 times 6 is 12. Now if I add together what's inside the radical, that becomes 49. 1 plus 48 is 49, divided by 12. Now if I take the square root of 49, that's 7. So -1 plus or minus 7. Now plus and minus 7 takes care of the square root of 49, because remember that could be 7, positive 7, or -7. So this takes care of it. So over 12. So we really have two problems here. You got -1 plus 7 over 12, and -1 minus 7 over 12. Okay, so that plus or minus, so this case had the plus, this one had the minus. So -1 plus 7 is 6 over 12, gives you the 1/2. -1 minus 7 gives you -8 over 12. If I were to reduce that, I can divide both by 4. 8 divided by 4 is 2, so -2, and then 12 divided by 4 is 3. So like we said, last round we had, the answers were 1/2 and -2/3. Okay, so that's solving a quadratic using the quadratic formula. Hopefully this helped you kind of refresh your memory, or even learn how to solve different various types of equations. We had, one step, two step, square root, squares, absolute value, and quadratics.